There are several different types of network components that we might have that need power, but we need to install them where they're not in close proximity with an AC outlet. For example, maybe we have a wireless access point installed in a ceiling tile, not very close to an AC outlet. Or maybe we have a Cisco IP phone sitting on someone's desk, and even though the desk may have an AC outlet underneath it, we actually have to purchase an external power supply for this. Do we really want to try to plug in another power supply into the already overcrowded power strip underneath our desk? No, a much more elegant solution would be to power these devices as well as other devices such as video surveillance cameras. It would be more elegant to power those over the Ethernet cable that they use to connect into the network. That's what we can do with a technology called Power over Ethernet, or PoE. What we can do is have our PoE-capable switch plugged in maybe to some sort of redundant power, maybe an uninterruptible power supply like a UPS, and we can connect our devices into this PoE switch. And it's going to detect how much power those different devices need and provide that power. Let's take a look at some terminology surrounding Power over Ethernet. The first term I want you to know is PSE, Power Source Equipment. This is the device that's sourcing the power, like the name suggests. An example would be our Cisco Catalyst switch that supports Power over Ethernet. Another term that we see pop up is the powered device, the PD. That could be the Cisco IP phone, it could be a video surveillance camera, it could be a wireless access point. And now with the Internet of Things evolving, we're having more and more devices that can connect into our network. And of course, the Ethernet cable, that's sort of the connective tissue that connects the device with the network, and we're providing not only data over that Ethernet cable, we're also providing power. And over the years, there have been different Power over Ethernet standards. I remember when I first worked with Power over Ethernet, it was using Cisco's proprietary Cisco Inline Power, it was called. That was back around the year 2000, 2001, and it provided 7.7 watts of power, which was plenty to support the Cisco IP phones that were available at that time. Then, around 2003, the IEEE started coming out with their own Power over Ethernet standards. They introduced something called 802.3AF, and that gave us 15.4 watts of power. It's interesting, isn't it, that that's exactly double the Cisco proprietary value of 7.7 watts? Exactly double that is the first standard, 15.4 watts. Then, as time went on, there was another standard that came out, 802.3AT, and it could provide a maximum of 30 watts of power. And by the way, your Cisco Catalyst switches may support a subset of these standards that we're talking about. I'm just wanting to give you a comprehensive overview of the standards that are out there, but a particular standard may not be supported on your switch. Check your switch's documentation. At the time of this recording, the most recent entry into the PoE standards field is IEEE 802.3BT, which can give us a whopping 100 watts of power. And now that we've talked a bit about the need for and the theory of Power over Ethernet, let's go out to a Cisco Catalyst switch and see how we can tweak it on one of our switches. Here we're sitting on a Cisco Catalyst 3560 series switch that does do Power over Ethernet. And it has PoE enabled on all of our ports by default. And we can confirm that by saying show power inline. And we can see that the administrative mode is set to auto for all of these different ports, meaning that if a PoE capable device is plugged into that port, it will negotiate with the switch how much power it needs. And we see that on this particular switch, it looks like we're running the 802.3AF standard because we support a maximum of 15.4 watts of power per port. And currently I have a couple of PoE devices connected. I've got a couple of Cisco IP phones, a couple of 8845s. And even though those are fairly new phones, they have a color display, they have a video camera, you'll see that they're only consuming 6.4 watts of power. Now, sometimes if you're on a modular switch where you're plugging in Ethernet blades and that blade supports Power over Ethernet, there are some situations where you can oversubscribe the modular switch's power supply. The power supply isn't of a size that can handle all ports simultaneously providing maximum power. So you might want to go in from time to time and adjust the maximum power available off of a particular port. Let's see how we can do that. Let's go into global configuration mode. And let's take a look at interface fast Ethernet 0/4. Let's change its maximum available power. Currently, it's 15.4 watts, but let's say for interface fast Ethernet 0/4, we'll say power inline auto. And actually, let me show you some context-sensitive help before we enter that command. Notice that there's not an on option. We don't want to provide power to an unsuspecting device that we connect into a port, but auto will detect if we need power. So I'll say power inline auto, and we can set the maximum amount. And I'm going to set the maximum amount, and the unit of measure is in milliwatts. I'm going to set the maximum amount to 6400, which is the 6.4 watts needed by one of my Cisco IP phones. So we'll set that as our maximum amount. And now we can confirm that. Let's once again issue the command show power inline. And we can see that even though it's not currently being used, fast Ethernet 0/4 now has a maximum wattage that it can provide of 6.4 watts. Well, that's a look at the theory and the configuration of power over Ethernet.